The James Webb Space Telescope, JWST, has made some discoveries that are so profound and unexpected, they have shaken the very foundations of our understanding of the universe. What was once a clear narrative of the cosmos, neatly tied to the Big Bang theory, now seems to be unraveling before our eyes. For the first time in history, we are questioning whether the textbooks that describe the origins of the universe need to be rewritten. If the findings of the JWST hold true, we may have to rewrite the entire story of how the universe came into being, how galaxies formed, and even how life as we know it began. This is not just a minor revision in our scientific understanding, it could be a complete transformation of our cosmic history. The Big Bang Theory, the foundation of cosmology for over half a century, the Big Bang Theory has been the dominant explanation for the origin of the universe. According to this theory, the universe began as an incredibly hot, dense, and uniform point around 13.8 billion years ago. In the moments following the Big Bang, the universe expanded rapidly in an event known as cosmic inflation. This expansion continued, giving rise to the galaxies, stars, planets, and even life that populate our universe today. The discovery of the cosmic microwave background, CMB, radiation in the 1960s provided the final confirmation of the Big Bang, cementing it as the foundation of modern cosmology. But now, in a groundbreaking turn of events, the James Webb Space Telescope has thrown some serious questions into the mix. Its infrared sensors have peered into the farthest reaches of space and the earliest moments of the universe, revealing discoveries that challenge the assumptions upon which the Big Bang theory was built. Are we truly ready to abandon everything we thought we knew? Massive galaxies in the early universe, a cosmic shockwave. One of the most staggering revelations made by the JWST is the discovery of massive galaxies forming much earlier than expected. These galaxies, which appear to be as large as, or even larger than, our own Milky Way, existed just a few 100 million years after the Big Bang, an era that should have been populated by much smaller, less developed galaxies. This is a huge problem for our existing models of galaxy formation, which suggest that galaxies formed gradually from smaller clumps of stars and gas over billions of years. But the JWST has observed galaxies that are far more mature and massive than current theories allow. Some of these galaxies are home to stars with masses billions of times greater than our Sun. One galaxy, in particular, has a stellar mass 100 billion times that of the Sun, an incomprehensible number. To put it in perspective, the Milky Way has stars equivalent to over 60 billion suns. These findings suggest that galaxies in the early universe were far more developed and formed far more quickly than anyone anticipated. This discovery has left the scientific community reeling. How could galaxies so large and mature exist just a few 100 million years after the Big Bang? Was the universe really that efficient in its early stages? These questions have created a cosmic puzzle that could force us to rethink everything we know about the birth of galaxies. Rethinking galaxy formation, what caused such rapid growth? The idea that galaxies could form so quickly in the early universe is not just an interesting scientific curiosity, it fundamentally challenges our understanding of how galaxies are supposed to evolve. According to the prevailing theory, galaxies form gradually. First, small clumps of gas and dust begin to collapse under their own gravity, slowly creating the first stars. Over billions of years, these stars cluster together, forming larger galaxies. But the recent findings from the JWST suggest a different picture. These enormous galaxies appear to have skipped this gradual process. Instead, they seem to have formed almost overnight in cosmic terms. Some astronomers believe that supermassive black holes, which are thought to lurk at the center of most galaxies, may have played a major role in this rapid formation. It's possible that these black holes grew quickly in the early universe, pulling in massive amounts of gas and dust, which then formed stars at a rate never seen before. While some scientists propose that the light from these distant galaxies might not be coming from stars at all, but rather from the accretion disks of black holes, the question remains, how did such black holes form so early in the universe's history, and what does this mean for our understanding of cosmic evolution? The need for new models of the universe. The implications of these discoveries are profound. If the universe truly formed these massive galaxies much faster than previously believed, it suggests that the models we've relied on for decades may need to be updated, or completely abandoned. For decades, cosmologists have relied on the lambda cold dark matter, lambda CDM, model, which posits that dark matter and ordinary matter were intimately mixed in the early universe. According to this model, galaxies formed slowly as dark matter halos collapsed and stars began to emerge. However, these new findings suggest that there may have been more dark matter or ordinary matter present in the early universe than the lambda CDM model predicts. Perhaps the universe was far more efficient in its early stages than we thought, with galaxies forming at an accelerated rate due to unknown processes. In light of these revelations, many cosmologists are calling for new models of cosmic evolution that take into account the possibility of more rapid galaxy formation and the potential involvement of supermassive black holes. Roger Penrose's radical theory, the end of the Big Bang. Adding to the mystery, another provocative idea comes from Nobel laureate Sir Roger Penrose, who has long challenged the Big Bang theory. Penrose's theory, called conformal cyclic cosmology, suggests that the universe we live in might not be the first, nor the last, in a never-ending cycle of birth and rebirth. According to Penrose, the universe goes through cycles of contraction and expansion, with each cycle beginning with a Big Bang and ending in a Big Crunch, where all matter collapses back into a dense, low-entropy state. This is a radical departure from the Standard Model, which holds that the Big Bang was the singular beginning of time and space. Penrose's idea is supported by some puzzling observations, including the discovery of what are called Hawking points in the cosmic microwave background, CMB, radiation. These points, which appear to be unusually hot, might be evidence of black holes from a previous universe, suggesting that the current universe is merely the latest in a long series of cosmic rebirths. If Penrose's theory is correct, it would mean that the Big Bang did not mark the true beginning of the universe, but rather the start of a new cycle in a much older, ongoing process. The future of cosmology, more questions than answers. So where does all of this leave us? As scientists continue to analyze the data from the JWST, one thing is certain: we are at the precipice of a revolution in our understanding of the universe. While there are still many unanswered questions, such as whether these massive galaxies really exist as they appear, or if they might be black hole systems in disguise, the discoveries made by the JWST have already changed the way we think about the cosmos. The telescope's findings raise more questions than answers, and it is clear that we have only just begun to scratch the surface of what could be one of the most profound scientific breakthroughs of our time. As we wait for more data to come in, the possibilities are both thrilling and terrifying. Could the universe be far older, more complex, and more mysterious than we ever imagined? Are we on the cusp of discovering that the history of the universe is far stranger and more wondrous than anything we ever dared to dream? One thing is certain: the James Webb Space Telescope has forever changed our understanding of the cosmos, and we are just beginning to understand